Commuter trains are built to move large numbers of people between suburbs and city centers, especially during the morning and evening rush. They usually run on fixed schedules, stop at many stations, and are designed for quick boarding rather than long-distance comfort. Most use electric power from overhead wires or a third rail, though some still use diesel engines. Inside, you often find simple seating and lots of standing room, because trips are usually short. What makes them efficient is that one train can carry the load of many highway lanes of cars. A surprising fact is that some of the busiest commuter rail lines can move tens of thousands of people per hour into a city, making them one of the most space-saving transport systems ever built. Metro trains, also called subways or underground trains, are high-frequency city rail systems designed for short trips within dense urban areas. They usually run on their own tracks, separate from road traffic, which lets them arrive every few minutes. Most are electric and draw power from a third rail or overhead wires. Their cars are built for fast boarding, with wide doors and open interiors so many passengers can fit inside. Because they avoid traffic lights and road jams, metros are one of the fastest ways to cross a busy city. An interesting fact is that the word underground can be misleading. Many metro systems run partly or mostly above ground, depending on the city's geography and history. Light rail trains are a middle ground between street-running trams and full metro systems. They usually carry more people than a tram, but less than a heavy subway train, and they can run in several ways: on city streets, on reserved lanes, or on separate tracks. Most are electric and use overhead wires. Light rail works well because it can serve downtown streets and then continue into outer neighborhoods without forcing passengers to change. The trains are often shorter and lighter than metro cars, which is where the name comes from. A neat real-world fact is that many modern light rail systems were built by reusing old freight or industrial rail corridors, turning forgotten tracks into busy public transport again. Trams, also called streetcars in some places, are rail vehicles that usually run along city streets and share space with cars, bikes, and pedestrians. They are powered mainly by electricity from overhead wires and stop frequently, making them useful for short urban trips. Unlike buses, trams ride on steel rails, which gives them a smooth path and lets one driver move many passengers at once. They work best in busy corridors, where a city wants reliable service and lower emissions. One interesting fact is that trams were once common in hundreds of cities, then disappeared in many places as cars took over. Today, many cities are bringing them back because they can shape walkable neighborhoods and encourage development along the line. Regional trains connect towns and smaller cities within the same wider area, usually over distances longer than commuter trips but shorter than intercity travel. They stop more often than long-distance express trains, serving many communities along the route. Depending on the network, they may use electric power or diesel engines. Their cars typically offer more seating and comfort than metro or commuter trains because journeys are longer. Regional trains are important because they tie together local economies, schools, hospitals, and jobs without requiring everyone to drive. A surprising fact is that in some countries, regional rail lines are the backbone of everyday mobility, carrying students, workers, and shoppers all day long, not just during rush hour. Intercity trains are designed to connect major cities over medium to long distances. They usually make fewer stops than regional trains, allowing higher average speeds and shorter travel times. These trains may be electric or diesel depending on the route, and they often include more comfortable seating, luggage space, restrooms, and sometimes food service. Their main job is to offer a practical alternative to driving or short flights. Intercity service works by balancing speed with coverage, stopping only at important population centers. An interesting fact is that before widespread air travel, intercity trains were the main way people crossed entire countries in comfort. And in many places they are becoming popular again as travelers look for lower carbon ways to move between cities. High-speed trains are built to travel much faster than ordinary rail, usually on specially designed tracks with gentle curves, advanced signaling, and strong safety systems. Most are electric, because electric motors provide smooth acceleration and high power. These trains are streamlined to reduce air resistance, and their wheels and suspension are carefully engineered for stability at very high speeds. High-speed rail works best on busy routes between large cities, where it can compete with air travel. A famous example is Japan's Shinkansen, known for speed and punctuality. The surprising fact is that on many routes, high-speed trains can beat planes door to door, because stations are often in city centers, while airports are farther away and require long check-in times. Long-distance passenger trains are designed for journeys that can last many hours or even several days. They connect far-apart regions and usually offer features that short-trip trains do not, such as reclining seats, sleeping cars, dining service, and larger luggage areas. Some are pulled by locomotives, while others are self-powered train sets. They may use diesel or electric traction depending on the route. These trains work by combining comfort with endurance, allowing people to travel overnight and wake up in another city or region. One fascinating fact is that some of the world's most famous long-distance trains became symbols of adventure and luxury, but they also served a practical role by linking remote communities long before highways and airlines reached them. Sleeper trains are passenger trains specially equipped for overnight travel, letting people sleep while the train keeps moving. Instead of only regular seats, they may have couchettes, private cabins, bunk beds, washrooms, and sometimes showers or dining cars. The idea is simple. Save daytime travel hours by turning the journey into a night's rest. Sleeper trains can be part of long-distance networks or international routes, and they are powered the same way as other passenger trains on the line, usually electric or diesel. A surprising fact is that sleeper travel is seeing renewed interest in some regions because it can replace short flights while avoiding hotel stays. For many travelers, the appeal is not just transport, but the experience of waking up in a new place. Tourist and scenic trains are designed less for speed and more for the travel experience itself. They often run through mountains, forests, coastlines, deserts, or historic regions where the views are part of the attraction. Some use modern coaches with large windows, while others use restored vintage cars to recreate the feel of earlier rail travel. These trains may be pulled by diesel, electric, or even steam locomotives depending on the route and purpose. They work by turning transportation into sightseeing, often with commentary, special meals, or open observation cars. An interesting fact is that some scenic railways were originally built for mining or freight, but after industry changed, the lines found a second life by carrying visitors instead of cargo. Freight trains move goods instead of passengers, carrying everything from food and fuel to cars, timber, and containers. They usually consist of a locomotive or several locomotives pulling a long line of specialized wagons, each built for a different kind of cargo. Freight rail works because steel wheels on steel rails create very low rolling resistance, so one train can move huge loads using less energy than many trucks. Depending on the network, freight trains may be diesel or electric. A surprising real-world fact is that the longest freight trains can stretch for several kilometers, especially in places that haul coal or iron ore. These trains are a hidden part of daily life, delivering the materials and products that keep stores, factories, and cities running. Container trains are a major type of freight train built to carry standardized shipping containers, the metal boxes seen on ships, trucks, and rail wagons. Because the containers are the same basic sizes worldwide, cargo can move from ship to train to truck without unloading the goods inside. That simple idea transformed global trade. These trains usually use flat wagons, and in some countries containers are stacked too high to save space. They are pulled by diesel or electric locomotives depending on the route. An interesting fact is that the rise of container trains helped make modern supply chains possible, allowing products assembled from parts made in different countries to move quickly and cheaply across continents. Bulk freight trains carry large amounts of loose raw materials such as coal, iron ore, grain, sand, stone, or chemicals. Instead of containers, they use open-top wagons, covered hoppers, tank cars, or other purpose-built vehicles suited to the cargo. These trains are designed for volume and efficiency, often running between mines, ports, factories, and power plants. Loading and unloading are usually highly mechanized, with chutes, conveyor belts, or bottom-release doors. Because the cargo is heavy, bulk trains may use multiple locomotives spread through the train for extra pulling power. A surprising fact is that some of the heaviest trains ever operated are bulk trains, moving so much material in one trip that they can replace hundreds of truck journeys. Diesel trains are powered by onboard diesel engines, which makes them useful on routes without electrified tracks. In many cases, the diesel engine does not directly turn the wheels. Instead, it powers a generator that sends electricity to traction motors on the axles, combining the flexibility of diesel fuel with the control of electric drive. Diesel trains can be locomotives pulling coaches or self-contained multiple units carrying passengers. They became popular because they were cleaner, faster, and easier to operate than steam trains. An interesting fact is that diesel trains helped railways modernize in the 20th century by reducing the need for constant water stops, coal handling, and the large maintenance teams that steam locomotives required. Steam trains are powered by steam pressure created by heating water in a boiler, traditionally by burning coal, wood, or oil. The steam pushes pistons or turbines that drive the wheels, turning heat into motion. Steam locomotives were the machines that launched the railway age, making fast land travel and large-scale freight movement possible in the 19th and early 20th centuries. They required constant work, with crews managing fuel, water, pressure, and fire. Today, most steam trains survive in museums, heritage railways, and tourist operations rather than everyday service. A surprising fact is that steam locomotives were not just slow old machines. Some were incredibly powerful and fast, and a few set speed records that amazed the world in their time. Hybrid trains combine two power sources so they can operate more flexibly and often more efficiently. A common example is a train that uses electricity where overhead wires exist and switches to diesel or battery power on non-electrified sections. Some hybrids also store braking energy in batteries to use later when accelerating. This approach helps railways reduce fuel use and emissions without electrifying every kilometer of track at once. Hybrid technology works especially well on routes that mix busy city sections with rural branches. An interesting real-world fact is that hybrid trains can quietly enter stations or tunnels on battery power, cutting noise and fumes where people notice them most, while still keeping the range needed for longer journeys. Hydrogen trains use hydrogen fuel to generate electricity onboard, usually through fuel cells. The fuel cell combines hydrogen with oxygen from the air, producing electricity to power traction motors, with water vapor as the main direct exhaust. Many hydrogen trains also carry batteries to store extra energy from braking and help during acceleration. They are aimed at lines where diesel trains still operate, but full electrification is difficult or costly. The idea is to get electric style running without overhead wires everywhere. A surprising fact is that whether hydrogen is truly low carbon depends on how the hydrogen is made. If it comes from renewable energy, the environmental benefits can be much greater than if it is produced from fossil fuels. Locomotive-hauled trains are made of a separate powered locomotive, pulling or pushing unpowered passenger coaches or freight wagons. This is one of the classic train layouts and is still widely used around the world. The locomotive contains the engine or electrical equipment, while the other cars are built mainly for carrying people or cargo. This design works well because operators can change the number or type of cars depending on demand, and locomotives can be swapped when routes change from diesel to electric or vice versa. An interesting fact is that some passenger trains use a locomotive at each end, which avoids the need to turn the train around and can improve acceleration and reliability on busy routes.